Hi everyone, so I'm a GameVids here with a new video for you guys. Today we're going to be taking a look at a hardware focused video. We're going to be taking my Intel 8th generation powerhouse of a chip, the 8700K, and we're going to be going through the process of delidding. So what is delidding, you might ask? Delidding is when you remove the integrated heat spreader or the metal component on top of your CPU from the die itself. And the reason you want to do this is you can generally lower temperatures by replacing the thermal interface that Intel gave you with something called liquid metal. And again, this does technically void your warranty, so you do this at your own risk, but if you follow the steps in my tutorial, and there's many online, you'll see that the process is fairly straightforward, and it's as long as you follow the steps correctly, you should be in safe territory. And yeah, I'm gonna go through the different steps in order to do the delid process, and as well as relidding the IHS to the CPU. I'm going to show you what materials that I use, and then I'm going to show you the results. So you're in for an exciting video, and I hope to bring you some more hardware reviews in the near future. I have at least one more cooking in the oven. It's just taking me a little bit of time because I've been busy with other things. But yeah, without more further talking about this, let's just show you the process. Okay, so let's take a look at some of the tools that you're going to need for the delid guide. First, we're starting out with DeBauer's delid kit for Intel based CPUs. You can also use this on Ryzen CPUs, but definitely watch his guides to see how you could do that. This kit is pretty high quality, I would say. It's one of the better delid kits that I saw online. It's all metal construction, so I liked it. And you'll see how it works in a couple of seconds. Okay, next we have the NTH1 Noctua thermal paste. This is what you're going to put on top of the IHS later. Some nail polish to protect some of the electrical components in the CPU. Thermal Grizzly's Conductonaut. This is the liquid metal. This is some black gasket paste that you're going to use to relid the CPU if you want to. Some painter's tape to protect different parts of the CPU when applying the thermal paste, the liquid metal. Some paper towels for cleanup. A little credit card or plastic piece to help get rid of the glue. Some scissors, as well as some isopropyl alcohol. Okay, so we're starting the delid process by putting the CPU inside of the delid kit. You attach the metal portion on top, and then basically insert the screw with the washer, and then you basically just turn on, insert the Allen key into the screw, and basically you're gonna just turn slightly until you see the IHS kind of move forward. You don't need that much pressure, and then there you have it. You have your IHS delidded from the CPU. And yeah, as you can see, the thermal paste didn't really seem to stick that well to the CPU. It's almost clear. And this is kind of the main reason why when you overclock, at least on the 8th generation Intel chips, you're not really getting the best temperatures, because the thermal paste interface that Intel uses is basically crap. So the next thing I did was I just made an outline using my razor on the IHS where the thermal paste sticks there. Why am I doing this? Because later I'm going to apply liquid metal, and you have to apply it to the IHS as well as the die. So this just makes it easier if you have a little outline of where it goes. Okay, so now I'm just cleaning the IHS off with some isopropyl alcohol wipes. You want to get everything as clean as possible. You also want to remove the glue, which I tried removing with the plastic, you could say plastic piece, but it really wasn't coming off that well, and then I basically transitioned over to the razor. And what you'll see me in the next couple of minutes is basically cleaning off both the IHS as well as the CPU from the glue. It just takes a while, and you gotta be careful. Again, it's easy enough to take off with the razor. You just have to be careful not to scratch the die, you know, when working with the CPU. And obviously the IHS, you can feel free to scratch it up, but just be careful, obviously, not to cut yourself. And it's a pretty straightforward process. It just takes a little bit of time. So now we're moving on to the CPU itself. We're going to remove the thermal glue that Intel has on it, and then also clean off the die itself. You want it to be as clear as possible. You should be able to see your reflection in it. That's how you know it's super clean. And then with the glue, you just got to be really careful. Again, I was using the razor, but you just want to be careful, and again, not to scratch up the CPU itself, and you don't also want to damage the any of the circuits on the CPU itself. So just be careful and take your time, and sooner or later you'll have a nice clean CPU that you will be able to then apply the liquid metal to. Okay, so this is what the CPU looks like, all cleaned up, free from the thermal glue from Intel, as well as the thermal paste that was on the die. So what you want to do next is take your painter's tape, take a couple pieces, and basically mask off the area that you don't want any liquid metal to get on. And this is just the easiest method. That way, if you apply a little bit excess liquid metal, it's going to stick to the painter's tape and not your, maybe electrical components on the CPU itself. You have to be very careful with the thermal paste. As you can see, I accidentally basically took out too much thermal liquid metal from the tube, and liquid metal has a very unique, you could say, like property in terms of, like, it's not really, it is liquid, but it also kind of acts like a solid. As you can see, I'm picking it up and it's kind of still holding its, like, you could say, shape. So yeah, you have to be a little bit careful applying the liquid metal. You also don't need too much, so if you unfortunately scoop some extra out, just use the suction of the tube to basically like try to pull it back in. And then yeah, you just need a little bit applied to the die, and you want to see a nice clear coat. So I went over this like several times just to make sure it was nicely coated, because I didn't want to have to relid the CPU, and what you want to be able to see is your reflection, and basically no holes or gaps on the CPU where there's maybe no liquid metal applied. So just keep doing it over and over again until you feel like you have a nice clear uniform coat, and that there's no basically no like spaces where the die doesn't have any liquid metal, and also that you don't have any imperfections. Like, it should be uniform, and if you do have any imperfections, that you're probably going to see some of the cores get hotter than others when you're doing your overclocking test. After you're done applying the liquid metal to the CPU, you're going to do the same thing to the IHS, again masking off portions of the IHS where you're not going to apply any liquid metal. And again, just feel free to be generous with the liquid metal. You just want to make sure it's coated on both sides. This provides the best basically transfer of heat from the IHS to your air cooler or your your water cooler, whatever you're using. So this step is very important. Don't forget to do this. Okay, so what you want to do now is basically remove the masking tape from the painter's tape from the CPU as well as the IHS, and you can do the additional step of applying the nail polish to the CPU just to protect those few electrical components right near the CPU. Sometimes when you put the IHS back on the CPU, some of the liquid metal spills over onto the die, but that's the only electrical components that are kind of close to it, so that's why you want to protect them. You're then going to apply your gasket paste to the CPU IHS if you want to relid, which is in my case I wanted to do that. Sometimes people don't want to relid, so they just basically put the IHS on top and they don't use any paste. It's up to you what you want to do. Some people prefer not to put the paste. I did just because I didn't want it coming apart and then having further issues and having to delid again. So that's what you're going to see in the next couple minutes. Just me applying the paste to the IHS. And something you want to keep in mind is you don't want to go crazy with this. You don't want to rock solid seal. You want to leave it kind of loose a little bit, so that way any gas can escape. And that's the way Intel kind of had sent out the CPU when they basically manufactured it. So they left a little bit of gap for the air to escape. So that's what you should be doing as well. And finally, we get back to where we want to be, is where we want to basically put the IHS back onto the CPU, and then you're going to use DeBauer's tool to basically kind of clamp down the IHS to the CPU, and it's recommended that you wait about like 30 minutes. I think I waited about an hour just to make sure the seal was good, and then yeah, you could put it back into your computer, and then you could run some benchmarks, and you should hopefully see a temperature difference when you're overclocking. We've had a chance to look at the whole delidding process. Let's see what the results were. So when I replaced the thermal compound that Intel gave me with the liquid metal thermal Grizzly's Conductonaut, these were the results. And as you can see across the board in various different benchmarking applications, I was seeing a reduction of temperatures between about 13.6 degrees Celsius to all the way to 22 degrees Celsius. And all of these different programs, they are indicative of, in my opinion, some good real-world stress testing benchmarks. And this is these are different tests that most tech tubers were using. I've tried to stay away from Prime 95 because, again, in my opinion, it is a very unrealistic workload. Obviously, if your overclocking would withstand the insane heat and insane heat as well as the insane load on your CPU, that's all good for you. But for me, I just didn't feel the need for those kinds of tests. So let's just start with real bench real quick. So before the delid, with my 5 gigahertz overclock, I was getting about 93 degrees Celsius, and then after the delid with the liquid metal, I was getting about 72.6 degrees Celsius. So it's a reduction of about 20.4 degrees. With Cinebench R20, the single thread results were cut by about 13.6 degrees Celsius from 65.6 to 52. In the multi-thread, you'll see a nice reduction in temperatures from 92.3 degrees Celsius to 73.6. In OCCT, which again is a very CPU stressing benchmark, you went from 94.3 degrees Celsius to 72.3. And then finally POV Ray, it went from 91.3 to 70.6, which is a reduction in 20.7 degrees Celsius. So as you can see across the board, the delidding process along with the liquid metal really made a difference. So this is definitely a step that I would encourage 8th gen, particularly 8th gen owners. 9th gen, they had a better thermal interface compound, and it's a little bit harder to remove the thermal paste, and the results aren't as good as with the 8th gen chips because it's just a simple delid and then using the liquid metal. Yeah, so hopefully this tutorial helped you, and as some of you may wait to upgrade to the next gen Ryzen chips or 10 nanometer Alder Lake, which I'm pretty excited about. Although in recent years Intel has failed to deliver, so I'll just maybe be rocking my 8700K for a couple more years. If you guys like this video, make sure to hit the thumbs up button, and if you haven't subscribed already, please do so. It helps the channel. And yeah, just write in the comments below if you've tried this process or you've been thinking about it, maybe some of your questions, and I'll do my best to answer them. All right, have a good one. I'll catch you guys in the next one. Peace.